This question says a circular loop of radius this carries current this and has a unit of unit normal vector of this. What is the x component of the torque on this loop when it is placed on the magnetic field this? Okay, we asked to calculate the x component. Before we do that, let's write down our parameters. We're given that the radius r is equal to 0.5 meters, and as well we have the current to be equal to 3 amps, and the unit vector n is giving us 2i plus or minus j, 2i minus j plus 2k hertz divided by 3. And we have the magnetic field B to be equal to 2i minus 6j in Tesla. Okay, we know that torque is equal to T. The torque, tau, is equal to M cross B. And M is the magnetic moment. And M is giving us I, A, and the N hertz. So we have that I is equal to 3 amps, and the A, which is the area, and we're told that this is a circular loop of radius. So for the fact it's a circular loop, the area of a circle is equal to pi r squared. So we have that this is equal to, multiplied by pi r squared. R is 0.5 square multiplied by the unit vector, which is 2i minus j plus 2k divided by 3, and this is equal to, let's do some simplification here, and 3 can cancel 3, and we are having 0.25, or 0.5 square is 0.25, so this is 0.25 pi into 2i minus j plus 2k, and if I use the 0.25 to open the bracket, I'll be having this is 0.5 pi to be pi into 0.5 I minus 0.25 j plus 0.5 k. So this is what I have. Since we've gotten the M, this is M, so we are now free to substitute it back to this expression. This expression here, let me change the color. This expression here. And we're already given that the magnetic field is this. So what we have now is the torque, which is M cross B, is giving us pi into 0.5 I minus 0.25 j plus 0.5 k cross now the magnetic field, and the magnetic field is giving us 2i minus 6j So we have this to be equal to the tau. Let's put it into matrix. We have pi, the determinant of I, j, and k. So I have the I to be, for the magnetic moment, the I component to be 0.5, and this to be 0 minus 0.25, and the k component to be 0.5, and that of the magnetic field is 2. This is minus 6 and 0 or 0. So solving the determinant of this will give me this expression. You can go to the previous video we made on the matrix and determinant to clearly understand how to solve the matrix. So in this case, we have the tau to be equal to pi, open a big bracket, 0, this, and that should be 0 minus into minus 6 multiplied by 0.5 I, or another bracket, yeah, minus into this, that should be 0 minus this, which is 2 by 0.5 j plus this and this, that will be equal to, let me take the plus here, write the last part, which is plus, this will be minus 6 multiplied by 0.5 minus into 2 multiplied by minus 0.25, and this is k. There's a double bracket here, and we'll close the bracket. If you simplify this, you'll be having this to be equal to pi to be, this is 3i minus j plus j, okay, minus, yeah, plus j minus 2.5k. And we were told to determine the x component of the torque, then the x component will be equal to the x component of the torque will be equal to this 3 pi, and 3 pi is same thing as 9.4, then the unit of the torque will be Newton meter. Let's go back to our option and see if our solution is correct. So from the option, we can say that this is option D is the right answer.